Now let us go to one example of our presentation for lesson 1-2, which is about functions. So in this lecture and also an example, we are going to discuss about restricted domains and Boolean variables. So what is a Boolean variable? A Boolean variable is it's a variable. A Boolean variable is a variable that has a given condition. So remember this, you have a given condition. You have a condition. Okay? So you have a condition attached to it. Now if the condition is true, the variable equals 1. If the condition is false, the variable is 0. And notably, this could be found in the grapher, if you have the grapher. So let us take, for example, this function y is equal to 3x plus 26. Now this is a linear function. Linear function again because we only have an exponent of 1. Now this linear function will be defined for a certain domain only. So remember that our domain, again, our domain is the set of all the x values. So x values. Now in this example, in our linear function example 3x plus 26, we defined a certain restriction for your domain, for the x. So our restriction is, remember, our restriction is x is greater than or equal to 3, but x is less than or equal to 10. Now the other way to write this is through this one. We could compress the x in the middle. It's called a sandwich. It's a sandwiching. Okay, x is greater than or equal to 3, but less than or equal to 10. So x is greater than or equal to 3, and x is less than or equal to 10. Now that is what you call a restricted domain. Restricted domain because we are restricting our domain of x, which in this case for this function 3x plus 26, it has a lot of you could set any values for x and get any values for y also, but in this case we are restricting it to this domain 3. X is greater than or equal to 3, and x is less than or equal to 10. Okay, let's move on to example 1. In our example 1, plot the graph of fx is equal to negative x squared plus 5x plus 3 in the domain 0 or x is greater than or equal to 0 but less than or equal to 4. That's our domain, so it's a restricted domain also. What kind of function is this? Give the range. Find a pair of real-world variables that could have a relationship described by a graph of this shape. So first, we are going to draw a table. Okay. We're going to draw a table. Okay, we have, let's set our parameters, our x and y values. So let's set our x and y values. Okay, by first of course creating a table of x, possible x values and y. So in this case, this would be our x, and this would be our y. And remember that our domain lies from 0, in between 0 and 4. Okay, we have a grapher here. Let's just move the axis. Let's move the axis. Okay, and this one. Okay, let's just do it by that. So we have x is in between 0 and 4. So let us have in between x and 4. So we have x and 4. We're going to write the labels for x and for the x values 0 to 4. Okay, and here also we're going to set some units. Okay, now we've got, this is our x again, and this is our y. Now we have 0 here. This is the origin. This is 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then let's get the values. For x is equal to 0. 1, 2, 3, 4. Now if our x is equal to 0, so our f of 0 would be, our f of 0 would be equal to negative 0 square plus 5 times 0 plus 3, and this would give us 3. So we have a value of 3 here. Now if our x is equal to 1, that would give us negative 1 squared plus 5 times 1 plus 3. So that would give us a value of, this is 1 plus 5, that's 6, we have 9. So we have 9 here. Now if our f, or if our x is equal to 2, we have negative 2 square plus 5 times, I'm sorry, that's 2, not negative 2. 5 times 2 plus 3, this would be equal to 4 plus 10, that's 14 plus 3, 17. So we have 17. Now if our x is equal to 3, let's put it here. F of 3, that would be equal to, why did I think I made a mistake here. So it's negative 2 square plus 5 times 2 plus 3, that would be, okay, let me erase that one. Okay, we have, this is negative 4, negative 4, okay, let me, this one also, okay, it should be negative here, that's negative here, that's negative 1 squared, so that's negative 1, plus 4, or plus 5, negative 1 plus 5 is 4, plus 3, so that would be 7. 8 minus 1 is 7. Okay, if x is equal to 2, we have negative 4 plus 10, that's 6, plus 3, we have 9. If f of x, or if our x is equal to 3, we have negative 3 square plus 5 times 3 plus 1. So we get negative 9 plus 15 plus 1. So this is negative 9 plus 16. We have 7. So this is 7. Let me erase this. This is 7. This is 9. Now if our x is equal to 4, okay, that would be negative 4 squared plus 5 times 4 plus 1, so that's negative 16, plus 20, so that's 4 plus 1 equal to 5. Okay, now let us plot the points. So if x is equal to 0, y is equal to 3. So we have this plot. Okay, if x is equal to 1, 1 is equal to 7. So it should be here. If our x is equal to 2, our y is equal to 9. Six, 7, 8. This is 9. Okay, so if x is equal to 2, our y is equal to 9. Let me polish this thing here. Okay, 2 and 9, so would be here. Okay, now as you can see, if x is equal to 3, it becomes 7 again. So it would be here. Let me make this circular. Okay. And if our x is equal to 4, our y is equal to 5. Y is equal to 5. So we have 4 and 5. So it would be here. And we're now going to trace the graph by connecting all of the points in here. So we will get, as you can see, we are getting a curved path which at a certain x, okay, at a certain x, but remember that we have a restricted domain, so we're just only going to get the values of y from 0 to 4. So this is how your graph looks like. It is, what kind of function is this? Now, judging by the given function here, okay, judging by the given, okay, f of x is equal to negative x squared plus 5x plus 3. That is, what is that? It's a quadratic function. So it's a quadratic function. It's a quadratic function. Okay? What is the range? Now we get the range here. What is the range? Our range is the set of y values. So actually we have already gotten the range. And our range is these values here. So from 3 to 5. So let us write that in notation form, sandwich form. So we have our range . is equal to y greater than or equal to 3 but less than or equal to 9. That is our range. As you can see, from 3 and our maximum is 9 and our minimum is 3. So that's our range. Find a pair of real-world variables that could have a relationship described by a graph of this shape. Well, one example that I could give is projectile motion defined by, let's say, the relationship of the height of a ball and the time it is released. So, meaning your height, let's say, h of t is our function for the height, and it is dependent on t. So our height is the dependent variable and our time is the independent variable. So h of t is equal to, in physics, okay, this is equal to h0 plus v naught t plus 1/2 a naught t square, where our h0, our v naught t, and our e naughts, these are any random numbers, okay, any number, any element of real numbers. Okay, so that explains this exercise here. We determined that at the domain of x in between 0 and 4, we have a range which is in between 3 and 9, and this function is a quadratic function because its exponent is raised to 2, and a real life example would be a projectile motion defined by, for example, a ball, throwing a ball from a certain height. It could be 3 meters above the ground, and then throwing it upwards, and of course, a certain time, the ball will land to the ground.